This lesson will be on non-total and net ionic equations. I'd like you to pause the video and do this now. Determine the balanced chemical equation for the reaction between sulfurous acid and aqueous sodium hydroxide. Okay, so first we have to look for sulfurous acid, and in order to understand what that is, we look at the ending, the OUS. That tells me that that came from sulfite. And so then we go to our polyatomic ion list on our data table, and we see that that is actually SO3 2-. Now, when we have an acid, we know we combine it with hydrogen. So my equation starts with H2SO3, and all acids are in the aqueous state. We are reacting that with aqueous sodium hydroxide, sodium Na, hydroxide OH, and it's aqueous. Now, when these two things react, they are going to combine. The hydrogen is going to combine with the hydroxide to make water, and the sodium is going to combine with the sulfite to make sodium sulfite, which would be Na2SO3. It's Na2 because the sodium has a 1+ charge and the sulfate has a 2- charge. This state, we check our solubility table, or we remember that all group 1 ions, especially sodium, is soluble with everything. This would be our skeleton equation. Now we need to balance it. So we see that we have 2 sodiums on the right and 1 on the left. So we need to put a 2 in front of the sodium. Then we got to look at the water. We have 2 hydrogens and 2 hydroxides. So we must be making 2 water molecules. This is our balanced chemical equation. So that's just a quick review. Something that's really important moving forward is being able to determine chemical equations and balance them properly, including all states of matter. Non-total net ionic equations. Remember, the non-ionic equation is really just the standard chemical equation that we are so used to writing. Total ionic equations, we have to remember that we are dissociating all soluble ionic compounds and strong acids. They get dissociated. Anything else stays as is. So if we have a molecular substance, it will stay in the state that it is in. If we have a weak acid, it will stay in the same form. If we have any element, it will stay in the same form. Finally, we cancel our spectator ions to write down our net ionic equation. If needed, we may need to reduce the coefficients, which doesn't happen often, but it can happen. Here, we're going to continue on with that sulfurous acid and sodium hydroxide solution. So you have already written down the first equation. I'm going to rewrite that down right now. Well, here's our balanced chemical equation. Now we have to remember our rules. We dissociate all soluble ionic compounds and strong acids. So we look and we're like, okay, is H2SO3 a strong or a weak acid? And we check our data table. And if we look at that back section, you guys know what I'm talking about, the 6 strong acids. We see that sulfurous acid is not one of those 6. So this is a weak acid and it will not change. Sodium hydroxide is an ionic compound. It has a metal and a non-metal polyatomic. So we will dissociate this. Water, molecular substance, does not change. Finally, sodium sulfate is a highly soluble ionic substance. We will dissociate that. Moving on to our total ionic equation, H2SO3 aqueous is now reacting with 2 sodium ions, 2 Na plus aqueous, plus 2 hydroxide ions, 2 OH minus aqueous, to produce 2 water plus, again, I have sodium ions. Now, a common mistake is some people will do this. But if it's dissociating, we have 2 separate sodium ions, so I actually cannot write a subscript of 2. I have to put a coefficient of 2 to say that they are separated from each other. So 2 sodium plus ions plus SO3 2 minus ions. So there is our total ionic equation. Now we have to check our total ionic equation for spectators. What is the exact same on both sides? The only thing we can see here is we have 2 sodium ions on the left and the right side of the equation. So those are my spectator ions. I will get rid of those and rewrite the equation. H2SO3 aqueous reacts with really the 2 hydroxide ions. The sodiums just watch to make 2 water molecules and some sulfite ions, that are now in the solution. So this right here is our net ionic equation. We see that our weak acid is neutralizing our strong base to make water and sulfite. I'd like you to pause and try this one, and then I will have the solution up for you to check in a second. Have a look at the solution, see if it matches yours. Take some time to do the practice questions on page 2 and the first half of page 3 of your workbook. And if you do have any questions with those practice questions, please send me an email, or we can have a Google Meet and go over any questions you might have.